for my batteries for you. I can't find them. All right, guys and girls, our objective today is to talk about multiplying and dividing powers. So does anyone know or remember any rules of exponents before we start today? Mary, do you know or remember anything?
Well, there's the base, and then there's like the
Awesome. So here's the base, here's the exponent. What's the whole thing called? What's the whole thing called, Sean? Good. The whole thing is called a power. And then as Mary said, the exponent tells us how many times to multiply the 3. So 3 times 3, which is 9. So that's how you would evaluate it. Anyone know anything else about exponents or powers? Sean, what else do you know? Yes, big difference. Yes. 3 to the second does not equal 2 to the third. Very different. One of them's 9, one of them's 8, but you can't just flip them around. They're very different. Charles, what else? Yep, good job. We're going to actually talk about that in 4-7. That's scientific notation, yep. The calculator uses scientific notation as an E. We'll use it as times 10 to the something power, which I will show you when we get to lesson 4.7. It's kind of interesting. Annalise, what else? Good job. It's rated as repeated multiplication. 5 to the third is not 5 times 3. It's 5 times 5 times 5. Very good. Mary. Good job. We're going to talk about that. And you guys are good. All right, let's go over the warm-up, and then we'll get into the rules of exponents, which none of you guys said. These rules of exponents are pretty new. I don't think any of you have heard of them, so we're going to spend a lot of today talking about them. Okay, the warm-up. Briar, what did you get for number 1? That's the problem. You have to evaluate it. Did you not evaluate it? What does evaluate mean, Briar? Good. Solve or simplify. Charles, what did you get for number 1? Good. Alyssa, number 2. Oh, yeah, good. 125. I'm like, oh no. Number 3, Emma H. Good. Matt, number 4. Good. Jeremy, number 5. Good. 0 and 216 thousandths. You could also just say 216 thousandths. You could also just say 0.216. It doesn't matter to me. Adam, number 6. Good. 81 hundredths. Okay. Number 7. I know it's been a while. We need to find the least common multiple. I wanted to make sure you guys didn't forget this. What is the least common multiple of number 7? Emma M. Good. 56. Briar, what's the least common multiple of number 8? Awesome. Just so you guys aren't rusty, who can remind us what's the difference between GCF and LCM? GCF and LCM. Briar, what's the difference? Okay, what's the difference though? Like in how you find them. You're exactly right. So if you had factor trees, what do you take for GCF when you have factor trees? Good. So GCF, take what they have in common. What about LCM? What do you take on the factor trees? Prime. Good. And what if there's repeats? Good job. LCM, every prime number has to be represented. If there's repeats, you take the side that has the most. Annalise? Yeah, you did it too many times. You did 2 to the 6th. You tell me. What's the base? Yeah, so it'd be 2. Not 4 to the 5th, it's 2 to the 5th. Okay? Okay, any other questions on least common multiple, GCF, or anything on the warm-up? So not bad. Okay, first exponent rule is called the product of a powers property. Here's what this says. To multiply powers with the same base, you need to, I'm going to put a box around this, add their exponents. This rule is extremely important. To multiply powers with the same base, you need to add their exponents. And I'm going to show you a bunch of examples with this. To multiply powers with the same base, you add their exponents. What'd you say? Yeah, it's been a while since you guys have written with a pencil or pen, huh? Okay, here's an example using variables. If you multiply powers with the same base, for example, a to the m times a to the n, you're multiplying them, the base is the same, you rewrite the base, and you add the exponents. M plus n, we technically cannot add them because we don't know what the value is, and also they are not like terms. So this is an example using variables. Using numbers, let's say we have 4 to the third times 4 to the second. Rewrite the base, add the exponents. 3 plus 2 is 5. After you write that, I'll show you why that works. Yeah, don't do that. Mary. I'm going to show you. Hold on. I'm going to show you. Annalise, give me 1 second. Okay, so here's why. So 4 to the third, how many 4s are there? Annalise, how many 4s are there? Good. So there's 3 4s here. How many 4s are here, Charles? Hey, what happened to my smartboard? Okay, 2 here. So we have 3 4s here. We have 2 4s here. How many 4s are there? 5. So when you're multiplying same base, you add exponents. It's like you're writing them out in expanded form, and you're seeing how many objects, in other words, how many numbers there are. So that's why when you multiply and it has the same base, you add the exponents. 3 plus 2 is 5. Annalise? No, you keep it in exponential form. No, keep it in exponential form. So no, never multiply. Okay? You guys always, whenever we're doing rules of exponents, the point of this is so you keep your answer as an exponents. So keep it as a power. This is an exponential form. Do not multiply it through like you did on the warm-up. Don't multiply it, Annalise. That's what I just said. Don't multiply. You leave it like this. Charles. Yes, you may. So any questions on why that works? Sean. Yep. Yep. We're going to do a lot of examples with it. Okay. Zach, you okay? Just tired. Hey, Jeremy. Yeah, but don't did you hear what I just said? Don't multiply them together, okay? Annalise. Because that's not, so if you have 4 to the third times 4 to the second, and you changed it to 4 to the third times 16, you can't then say that that's equal to 4 to the, what were you telling me? It's equal to what? Because the directions are going to say keep it in exponential form. So you can't multiply. You have to keep it as an exponent. It's the same answer, but you're not supposed to simplify any further. You'll see why. We're going to do harder problems. Don't. No, don't change this to 4 times 4 times 4 or change this to 4 times 4. Do not do that. Keep it as an exponent. Okay, let's do some examples. Okay, example 1, it's going to say, now here's what Annalise is trying to ask. It says, find the product, but the directions are always going to say, write your answer using exponents. Do not multiply them out, okay? Letter A is 4 to the 7th times 4 to the 11th. So we have 7 4s here. We have 11 4s here. When you're multiplying and the base is the same, you add exponents. 7 plus 11 is 18. So your answer is 4 to the 18th. Rewrite the base, add the exponents. Rewrite the base, add the exponents. Okay, we have 2 to the 5th times 2 to the 12th. What is the answer to letter B? Alyssa? Good, 2 to the 17th. Rewrite the base, add the exponents. Do not change the base. Do not multiply them through. Annalise?
Now with my question, like why would she multiply the base?
Don't multiply the base because there's 3 4s here and there's 2 4s here. This 4 is not a 16, it's a 4. You can't change the value of that. If you change the value of that, the whole problem is wrong. You rewrite the base. Jeremy? Oh, I thought you had your hand up. Did you? Go ahead. Good. Letter C is 5 to the 11th. Rewrite the base. Don't change the value of the problem. Add the exponent. Okay, and in letter C, you had 6 plus 2 plus 3, which is 11. Okay, letter D on yours, the last one is just a B. What's really above the B? Zach? Yeah, this is really B to the first power. That really has one B there. So you have to take 2 plus 4 plus 1. Zach, what's the answer there? Good, B to the 7th. Okay, hold on. I want to add 2 more harder problems. Questions on the easy ones. Okay, at the bottom of that page or wherever you have room at that page, add letter E. Wherever you have room on that page, go ahead and add letter E. We're going to do it together though. Letter E is x to the 3rd, y to the 2nd times x. Okay, what 2 terms in E can we combine? So how can we simplify letter E? Annalise, how can we simplify it? Good. There's really a 1 here. So we can do x to the 3rd and x to the 1st to get x to the 4th. Rewrite y to the 2nd. Can we go any further? Why not? Why are we done, Briar? Yeah, the bases are different. You cannot go any further if the bases are different. So you stop right there. Okay, letter F. 2x to the 4th times 8x squared. If you didn't write that down, go ahead and write that one down. 2x to the 4th times 8x squared. This one's tricky. When I teach this in Algebra 1, I know that the 9th graders always get confused with this. Okay, what do you guys think? What do we do, Adam? Nope. That's okay, though. Good try. Good try, Matt. Good job. All you do here is multiply the coefficients, because they're just normal numbers. Multiply them like you would any other problem. Adam was trying to make it harder. And then when you're multiplying and it's the same base and it's in exponential form, add the exponents. So 2 times 8 is 16. Rewrite the x. 4 plus 2 is 6. Annalise? Because these are not in exponential form. These are just numbers. These are not in exponential form, so you just multiply them. The 2 and the 8 are just regular numbers. So you just mush them together. Alyssa? So if it was 2 to the 4th times 8 to the 2nd, you cannot go any further. You leave them like that because the bases are different. Good question. Mary? but the answers need to stay in exponential form. So you could, but we want all the answers to be in exponential form. Emma M?
So in part F, the x is the base.
Yep. Yep. These are just regular numbers. So if the x's weren't here, you would just multiply 2 times 8. That's all we're doing here is multiplying 2 times 8. They're just normal numbers. The coefficients in front you always multiply. You only add the exponents when you're multiplying and it's the same base. Annalise?
So when you have a 13 times 8,
That's it. That's your answer. You wouldn't go any further. That's what Alyssa asked. Because the bases are different, you can't do anything. Right, but the directions say keep it in exponential form. Well, yeah, and you could actually change this to be 2 to the something. Do you know what I'm saying? Yeah. Right, so you could change this, okay, to be 2 to the 6th. If you change that to be 2 to the 6th, then you could simplify further. But let me give you a different example. Let's say this was 3 to the 2nd. Could you simplify that any further? No, if it said keep the answer in exponential form, but don't multiply them together. You could simplify them, but if it said keep them in exponential form, then you'd have to keep it like this. Okay. One more. Go ahead and add letter G wherever you have room on that paper. Wherever you have room on that page. I like to add hard ones in for you guys. Okay, how do you do this one? Mary, what do we do? Good. Why can we not combine the x, y? Sean? Good. How else could you write the 2? Briar? Oh, yeah, you could do 4yx. Alyssa? How did you get 2 squared? Good. You could also do here, when you multiply same base, add exponents. If it's a problem like this, I don't care if you keep it in exponential form or the expanded form, which is when you actually multiply. So either one of these is fine because these are both to the first power. So it doesn't matter on that one. Annalise?
So you only multiply the bases together when they don't have exponents?
Yep. Whenever it's a coefficient, you multiply them together. Okay, next rule. Quotient of powers property. What does the word quotient mean? Alyssa? Good. Answer to a division problem. Okay, so listen carefully to this one. To divide powers with the same base, subtract the exponent of the denominator from the exponent of the numerator. To divide powers with the same base, subtract the exponent of the denominator from the exponent of the numerator. So I will show you how and why this one works as well, so you understand the role behind it. So when you're dividing and it's the same base, you subtract exponents. Mary? Okay. Donatus, you gotta keep your head up. Okay, here's an example from the book using variables. So if we have a to the m over a to the n, you rewrite the base, which in this case is an a, and you subtract exponents. M minus n. Rewrite the base, subtract the exponents. Now, the denominator cannot be 0. You'll see when we get to chapter 8. Okay, cannot have 0 in the denominator. You do not want it to be undefined. That's why I always put that with the algebra part. Denominator cannot be 0. I will explain that further in chapter 8. Okay, here's an example using numbers, and I'll show you why this works here in a second. So if we have m to the 7th over m to the 4th, or 5, thank you, I'm not sure why I said m. 5 to the 7th over 5 to the 4th, thanks Charles. You rewrite the base, you subtract the exponents. Now you do not have to actually write out the subtraction. I know you guys can subtract 7 minus 4. What I do is I go from this step right to this step. I'm just emphasizing this. What, Adam? Okay. So 5 to the 3rd is the answer. Now, before I taught you this, here's what you guys used to do. So here's how you figure this out. Writing out all the 5s, there's 7 on the top, there's 4 on the bottom. What do we typically do? Mary, what do we typically do? How many 5s are left? 3. Does that match up with this? Oh my gosh. Now do you see how it works? Isn't that so cool? Sean?
So you do it. Well, the denominator
Yep, that's tomorrow's lesson.
Okay.
Good job. So for now, Sean, I'm keeping it pretty simple and easy. It'll get harder. So we are dividing same base, subtract exponents. Before we do examples, questions on the roll. Okay, do some examples. Okay, letter A, 6 to the 8th over 6 to the 3rd. So you have 8 6s on the top, 3 6s on the bottom. Emma M, what's the answer? Good job. Letter B, we have 3x to the 7th over 12x to the 3rd. What do you think I'm going to tell you to do first with the 3/12ths? Alyssa? Not multiply, divide. What does 3/12ths become, Alyssa? Not sure? Okay, I'm tricking you guys. Charles? Good, how'd you get that? Yep. Do you guys remember on your calculator how to simplify fractions? Remember that shortcut I told you?
Yes.
Emma, how do you do it? Listen to Emma, guys. Yep. 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 Good job. So if you do 3 divided by 12, hit enter, and then go math, enter, enter. It simplifies it for you. This is just a basic simplify the fraction problem. Alyssa, does that make sense? Okay. I know you know that. 3/12ths becomes 1/4. So simplify the fraction. Now we have x to the 7th over x to the 3rd. When you divide same base, subtract exponents, it's always the numerator minus the denominator. You always keep it in the numerator unless it's a negative exponent. I will talk about that tomorrow. So today, when you're subtracting, always put it in the numerator. Mary?
You do 5 divided by 5.
Yeah? You could also write this as x to the 4th over 4. You don't need to have that 1 in front, but you can. Annalise?
So if we ended up with more x's on the denominator, let's want us to do that.
Always keep it on top, but that's tomorrow's lesson. That's not going to happen today. Okay, letter C, 5 to the 9th over 5 to the 2nd. What's the answer? 5 to the 9th over 5 to the 2nd. Zach, what's the answer? Good, 5 to the 7th. Rewrite the base, subtract the exponents. Okay, letter D. 4x to the 13th over 24x to the 9th. What should we do first on this one? What should we do first, Briar? Good. So, Briar, what is 4 over 24? Good. So 4 over 24 is 1/6. What does the x become, Donatus? X to the what? Nope. What do you do when you're dividing? Okay, does it go on the top or on the bottom? Good. So it becomes x to the 4th. It goes on the top. How else can we write our answer? Adam, how else? You could, but I'd rather you keep it as a fraction. All I wanted you to say was you could get rid of that 1. You don't need that 1 there. Okay, don't change it to a decimal. Okay? No. Okay, letter E and F I want you guys to try. Don't do the closing yet. Go ahead and try E and F. Don't do the closing yet because some of those are harder. Nope, no decimals. Nope. Simplify the fractions. Oh, that's okay. Thank you. Ooh. Oh, cool.
And then here's all the teams, and here's like the clues. My teacher gave me this worksheet.
Awesome. Okay, cool.
Some of them
I won't be able to do this, but let me make a copy of this. Thanks, Sean. Okay. Letter E. Let's see, Briar, what'd you get for letter E? Good. Jeremy, what did you get for letter F? Good job. Any questions on E or F, Annalise? Yep, just like we did the other ones. Okay. Emma. Go ahead. Yes. Did you not listen to me? How I kept saying? Always put it on the top. Yes, it matters. Until tomorrow's lesson, always put it on the top. Here's why. Tomorrow's lesson changes because after you subtract and you put your x on top, these numbers are going to be negative. You're not allowed to leave your answer as a negative exponent, so I'll talk about that tomorrow. So Emma, it always goes on top unless there's a negative exponent, which I will explain tomorrow in great detail. All right, let's do the closing together. Okay, letter A. These ones are a little crazy. If you see a multi-step exponent problem, I want you to simplify what's on the top first, what's on the bottom second, and then simplify the whole thing. How do we simplify the numerator? Let's start with that. Matt. Awesome. This was really a 1 here. 4 times 1 is 4. M to the 3rd times M to the 4th is M to the 7th. Now, is there anything to simplify in the denominator? Can we simplify the denominator? No. So rewrite your 12M squared. Okay, now that the numerator and denominator are simplified, now we just simplify the entire problem. Emma H, 4/12 is really what? Good, 1/3. M to the 7th over M to the 2nd becomes what, Annalise? Good. Nope, just M to the 5th. No M's on the bottom. After you subtract, you keep it on top. But we did 7 minus 2, which is 5. So you're not left with any M's. So you do not need to leave the 1 there. You can leave it as M to the 5th over 3. So simplify the numerator first, then the denominator, and then the whole fraction. Go ahead and try B and C. I like these problems. I think these are fun. So B and C, the numerator first, then the denominator, and then the whole thing. Good job. Awesome. Good job. That one's right. Yes. Okay. Numerator, yeah. So simplify that first. Then see if the bottom needs simplified, then do the whole thing. Okay? Awesome. Good job. Good job. Jeremy, how'd you get 6 to the third? Where'd your m go? Yeah, but you can't get rid of the m. You can't get rid of the m's. Okay. Okay. All right, Sean, letter B. Good. 2m to the third over 5. That is completely simplified. Donatus, letter C. Good. 2n to the fifth. Those are completely simplified. Annalise, question?
For B, I got 2m to the 4th.
Okay, so did you simplify the numerator first? So your numerator is 6m to the 6th over 15m to the third. Just rewrite the denominator. 6 minus 3 is 3.
Oh, I got 6m to the 6th.
How? Okay. Any other questions on either of those? Okay, let me show you guys one more problem. What do you think of what we did so far? Not bad? Multiply same base, add exponents, divide same base, subtract. Okay, at the bottom of your notes, write that down. 2x to the third, all raised to the second. 2x to the third at the bottom of that same page. Adam, you don't have to. Oh, okay. 2x to the third, all to the second. What do you think you do on this? This is something that's not in your book that I'm going to teach you tomorrow. I'm just curious as to see if you guys could figure this out or not. What do you think you do on this? Charles, what do you think? Okay, you're close. You're exactly right. You multiply the exponents. Say that again? How'd you get that? There's really a 1 here. Whoop. You're distributing the exponent. This is called the power of a power rule because, yeah, you have the exponent raised to a power. They call it the power of a power rule. I'll show you this tomorrow. Like I said, it's not in your book, but it's in the Algebra 1 book, which is why I'd like you to learn it so it's easier next year. So all you do is write this as 2 to the second, x to the 6th. This is a time when you have to multiply the exponents. What we learned today is you either add them or subtract them. If you have a power of a power, you multiply. Emma M? If the directions said keep it in exponential form, you have to keep it like this. Charles is right. I mean, 4x to the 6th is the same thing. But if it says write your answer using exponents, you have to keep it like this. I don't know. So I'm going to do more of these tomorrow. I'm going to make them harder. I just wanted to give you guys something to think about. Zach? Right, but the whole thing should be in exponential form. In other words, don't evaluate part of it. If it says keep it as an exponent. Okay? Mary? Yep, that's tomorrow's lesson. You guys are so smart. I mean, that's going to be a really difficult lesson, right? Anything to the 0 power is 1. I'll explain that tomorrow. Annalise?
So, like, I'm 0 power.
Nope, that's tomorrow. It's 1. That whole, yeah, that's tomorrow. Okay, open up your homework packet. You have a couple minutes to start to 4.5. Let me explain. Yep, you're going to do all. These are not going to take you very long. So here's what the directions say. Find the product or quotient. So they're mixed up. So you need to remember when you multiply same base, you add exponents. When you divide same base, you subtract exponents. Everything's mixed up. Write your answer in exponential form. That's for all of them. Flip over to the back for a second. Who can remind us for 25 to 27, how do you find area of a rectangle? Emma H. Yep, Length times width, so that's pretty easy. Look at 29 to 34. How do you do that? How do you find the missing exponent? Which, in other words, for 29 to 34, you have to find the question mark. Annalise, what would you do there?
Well, like for number C, you would have
Yep. Yep. Good job. So use your common sense there, like Annalise just told us. You need to find the question mark, which is the missing exponent. Okay, you guys have like a minute or two, actually 2 minutes to get started. So go ahead and get started. Okay, Adam, get started. Get started. You're going to be the last person in line.